Let's pick up where we left off. Check out this cool new pin I got. I don't remember if it was my kids or my wife or my mom that got this for me, but I just got it recently. I think my mom sent it to the kids as a Christmas present, and she sent 5 of them, so everybody in the house could have one. It can be so many colors. Now that we got that important information out of the way, let's do number 50. When you're multiplying, you do need things to be in improper fraction form. So 4/3 is all good, but we need to change this mixed number to be an improper fraction. So I do 5 times 10, which is 50, then add 3, that gives me 53. Okay, then see if there's anything diagonal to each other we can reduce. 3 and 53 have nothing in common, but 4 and 10 are both even, so I can divide them both by 2. 2 times 53 is 106. 3 times 5 is 15. And that will not reduce any further, so that is our answer. And I will specify this on the test, but I'll just tell you now in this video, when you're adding and subtracting mixed numbers, your answer should be a mixed number. However, when you're multiplying and dividing, I will accept it either way. If you want to change it back to a mixed number, feel free. But since we have to change it to an improper fraction to do the process, I'm fine with you just leaving it that way. 51, we're dividing by a fraction. To divide by a fraction, you must multiply by its reciprocal. And please remember, you only flip the second fraction, not the first one. Okay, and 2 and 6 are both even, so we can divide them both by 2. So we get 1 times 1 on top, and 3 times 1 on the bottom. Okay, using the distributive property on these next ones. Hopefully this has become a good habit for you now. It's pretty straightforward. 7 times 4 is 28. 7 times 6x is 42x. So whenever you're multiplying by 2 terms in in parentheses, that's where I wanted, you multiply both of them by that coefficient, that number outside. Okay, here we have to make sure, remember, it's a -6, so we do -6 times n, and -6 times 8, which is -48. Now on 54 and 55, we do need to distribute, and you need to do that first because we're still following the order of operations. So do not try to add 9 and 3 first. That will give you the wrong answer because distributing is just a form of multiplying. And as you know, with PEMDAS, multiplying comes before adding. So we've got to do the distribution because that's multiplying first. Now that we've done the multiplying and all we have is adding and subtracting, we can combine like terms if there are any, which there are. There's the constant 9 and the constant minus, or you can think of it as -6. So 9 minus 6 is 3. I'm just underlining it so you see where it's coming from. And then the 3x has no like terms, so it just stays as it is. 55 will have the same process. Well, these aren't like terms anyway, but even if they were, we cannot combine 8a plus 2 first because addition doesn't come before multiplication, and distribution is a form of multiplication. So 2 times 4a is 8a, 2 times 10 is 20. So 8a plus 8a is 16a, and this has no like terms, so we just leave it just as it is, and write minus 20. Okay, now it's time to solve equations. Remember, the goal is to get the variable by itself, and we have to do that by doing the opposite of what's being done to it at the moment. So here's what I mean. On part B, on 56, b is being divided by 11. So to get b by itself, we have to do the opposite of that and multiply both sides by 11. Because that then cancels out the 11s right here. We get 11 times -7 is -77, and b is now left on its own, and we have the right answer. That's what b is equal to. Okay, 57, we have a -5 plus n. We need to move that -5, so we do the opposite. You look at what sign is in front of the number always. The sign after the number doesn't matter. The sign in front of it is what matters. So the opposite of a negative 5 is a positive 5. So negative 5 plus 5 cancels out to 0. Negative 12 plus 5 is negative 7. You can figure that out by doing 12 minus 5, which is 7, and then keeping the sign of the bigger number, which is the 12. Okay, 58. This is one that I know has been a struggle all year long, so I'm trying to drive this home for the sake of your entire math career. When you see minus a negative, the very first thing you should do is change it to adding a positive. We're just applying the keep, change, change rule. We keep the y the same, change subtraction to addition, and change the sign of the number. So minus a negative always changes to plus a positive. So this is really y plus 3. So what we need to do to get rid of that positive 3 is subtract 3 from both sides, giving us y equals 9. Okay, on 55, what's being done to x right now is it's being multiplied by negative 5. We need to do the opposite to get rid of the negative 5 and divide by negative 5. And whatever you do to one side, you have to do the other. And anytime you have a negative divided by a negative, the result is positive. So 45 divided by 5 is 9. So those first four, 56 through 59, were all one-step equations. The next four are two-step equations. Now the process is still the same in that we want to do the opposite of what's happening, but we have to make sure we do it in the correct order. So we do need to move the 3 and the 10, but what's important is to make sure you do it in the correct order. So the thing I told you to think about is look and see what literally, the way this is written, is physically farther away from x. Well, the 3 is right there in the same fraction as x, whereas the 10's way over here. So the 10's farther away, so that's what needs to move first. So we have a minus 10. So our first step is to get rid of that 10 by adding 10 to both sides. Negative 3 plus 10, that's the same as 10 minus 3. The answer is 7. X is being divided by 3, so we can do the opposite by multiplying by 3. That cancels the 3's out, leaving just x. And 7 times 3 is 21. (61). It's b we want to get by itself. Again, there's a 4 and a 5 that we need to get rid of. The 4 is pretty much touching the b, so it's very close to it. The 5 is farther away, so we need to deal with the 5 first. And as I said earlier on a problem, you look at what sign is in front of the number, not the sign behind the number. So remember, there's an understood positive right here. That's a positive 5. So to get rid of it, we need to subtract 5 from both sides. So that negative stays because we've not touched anything behind the number. We've only done stuff with what's in front of the number. So we get negative 4b. 29 minus 5 is 24. Now it's negative 4 times b, so the opposite of that is dividing by negative 4. 24 divided by negative 4 is a negative 6, because anytime you have opposite signs, the result is a negative number. Okay, on 62, we have both a 6 and a 4 we need to move over. The 6 is basically touching the x, so it's very close. It's the 4 we need to move. We look at what's in front of the 4, which is a minus sign, so we need to do the opposite and add 4. Now we have 6 times x. We want to do the opposite of that, so we divide by 6, and we get x equals 4. Okay, 63. The 3 is in there with the r in the fraction, so they're close. The 2, though, is pretty far away comparatively. So remember, what's understood to be in front of the 2, even though it's not written, is a positive. That is a positive 2. So we subtract 2 from both sides. So we have r divided by 3. The opposite of dividing by 3 is multiplying by 3. So the 3's cancel, leaving just r, and 5 times 3 is 15. Next up, still solving equations, but this time we're solving equations that have variables on both sides. This is not required, but what I recommend is the first step you take is to combine the variable terms. In other words, we have a variable here, we have a variable here. And it's truly up to you. You can subtract 8p from both sides and still get the right answer, or you can subtract 9p from both sides. It doesn't matter. Personally, I would do the 8p just because that keeps you in positive numbers. That's not required. I'd just do that for ease. So that cancels out the 8p's. And then 9p minus 8p leaves us 1p. If you want to write the 1, you can, but you don't have to. Now, just like I wanted to combine the variables together, I also want to combine the constants, the numbers without variables together. So I want to get p by itself. So I want to get rid of this negative 16. So I look in front, that's a negative. So I add 16 to both sides. 11 plus 16 is 27. All that's left over here is the p. So we have our answer. Okay, 65. Again, we have two terms with a variable, in this case n. You can correctly solve this question whether you move the 4n or the 2n. Again, I'm going to prefer the 2n just because I like to keep the number positive, but it's not required to do that. That leaves 4 on the left side and negative 8 plus 2n on the right side. I want to get n by itself, so now I'm thinking just like the ones on the previous page that are two-step equations. The 2 is really close to the n, they're pretty much touching. The negative 8 is a little farther away. Since that's a negative 8, I'll add 8 to both sides. As that's 2 times n, I can do the opposite and divide by 2. And 12 divided by 2 is 6. Okay, 66. Now in this case, again, you are allowed to move either one. It's not that you can't get the right answer, but since I wanted to get the n's by itself, and this one has just n's on this side, it's quicker. It's not the only correct way, but it's quicker if I go and subtract the 6n over to this side. So 4n minus 6n is negative 2n, and I have a negative 12 left over. So again, this is the quicker way because that way I have all the n's on one side, all the constants, well there's just one, but still all the constants on this side. Then I divide both sides by negative 2 because that's the opposite of multiplying n by negative 2. These cancel out, and negative divided by negative is equal to a positive, so I get a positive 6. Okay, on 67, just so you know it works either way. Like honestly, I would move the 7x over there most of the time because that gives it a positive 3x, but just so you see it really does work either way, I'll subtract 10x from both sides. 7 minus 10 is negative 3x. Then I've got the variable all in one spot, but I want the constants to be all on the other side, so I'll subtract 9 from both sides. 3 minus 9 is negative 6. Then I divide both sides by negative 3. That leaves me with just x, and negative 6 divided by negative 3 is positive 2. And if you want proof that this does work both ways, the paper, the PDF I've posted with the answers, it shows me actually doing it the other way, subtracting 7x first. So you can see it gives the same answer either way. Okay, on 68, it says determine if each inequality is true or false. Be sure to show your work. My goal is not to give you 50-50 shot at guessing. That's why on these I want you to show your work. So it's telling you to plug 5 in for x. So we do 15 minus 5 greater than or equal to 8. 15 minus 5 is 10. So we ask ourselves, is 10 bigger than 8? It is. So this one is true. So on 69, we plug 2 in for x, so we get 120 over 2. 120 divided by 2 is 60. Is 60 bigger than 50? It is. So this one is also true. If you get an equation or an inequality that's not true, then you just write false. Okay, now these next few are inequalities. This really does work the same way as solving equations. The only difference is that when you multiply or divide by a negative number, then you have to flip the inequality sign. And we'll see an example of that soon. But otherwise, the process is the same. You're trying to get the variable by itself. So like on this one, we have a positive 18. So I'm looking at what's in front of the 18. It's an understood positive. So I'll subtract 18 from both sides. 18 minus 18 is 0, so that cancels out. It goes away. R is greater than 22 minus 18 is 4. On 71, we want to move the 17 over, and we look at what is directly in front of the 17. That's a negative sign. I know there's a plus here. That doesn't matter. We have a negative 17 right here. So we'll add 17 to both sides. 4 plus 17 is 21. Okay, 72. We want to get x by itself. Right now, x is being multiplied by 13, so we do the opposite. We divide by 13. We have a negative divided by negative divided by a positive. So our answer will be negative. 39 divided by 13 is 3. Okay, on 73, y is being divided by negative 3, so we need to multiply both sides by negative 3. That'll cancel out the negative 3's on this side, and because I just multiplied by a negative number, I've got to reverse the sign of the inequality and make it greater than or equal to. 6 times negative 3 is negative 18. So I want you to look at 72 and 73 and see why I treat these two differently. Because you might be like, well, we got a negative number here. Why didn't we flip the sign? We got a negative number here, and we did flip the sign. The answer has nothing to do with whether you flip the sign. What matters is whether what we divide or multiply is negative. So if you look at 72, we divided by a positive 13 on both sides. Since what we divided by was positive, we do not change the inequality sign. But on 73, we multiplied by negative 3. Since we multiplied by a negative number, we do flip the inequality sign and make it go the other direction. Okay, last two for this video, 74 and 75. Write an inequality for each graph. So just a reminder, an open circle means you do not put the or equal to line. So I'll just put x. You can use any variable you want. I don't care. And negative 1 is obviously the number. And this is all going to the left. Those are numbers smaller than negative 1, so we put x is less than negative 1. So because it's an open circle, I just put less than. I do not put less than or equal to. Open circles mean there's no line for or equal to. However, on 75, there's a closed circle, so we will put that line or equal to. So I put an x. I know negative 4 is the junction or the point where we making things happen. Those are all numbers bigger than negative 4. So I'd say greater than or equal to negative 4. So just so you know, the reason we do put that on the closed dot is the closed dot tells us negative 4 works. It's part of the solution set. So that's why I have to say or equal to, because negative 4 is part of the solution set. However, the open circle tells us negative 1 is not part of the solution set. Now every decimal, however, no matter how small you can imagine, that goes right up to negative 1 works. So negative 1.000001, that is part of the solution. So we use an open circle to tell us it goes all the way up to that point, but doesn't actually touch that point. So we don't put an or equal to.